to the video on application of special loads. In this video, you will learn to apply wind loads and seismic loads onto the previously modeled building. Open the building model that you had analyzed and designed previously. Wait for some time as the software loads the file. The wind and seismic loads are not defined by default, so you will need to define these load patterns first. Go to the Define menu and select Load Patterns. Here you may notice that the option for adding new loads are inactive. This is because the model was locked when you had run analysis previously. Close the Load Patterns dialog box and unlock the model. Click on OK to unlock the model. Now you can go to Define and select Load Patterns. Define the wind loads as of now. Type wind in the load option and select wind from the load type drop-down list. And in auto lateral load option, select the IS code for wind load calculation, that is IS 875-1987 as shown. After that, click on Add New Load. Now you can notice 3 loads in the loads patterns list. Keep the wind load selected and select Modify Lateral Load. Here you will be selecting the characteristics of the wind load. Keep the exposure and pressure coefficients option and wind exposure parameters option unchanged as shown. Under the wind coefficient option, you have to set the conditions for the calculation of design wind speed. For this part, you will need to refer to the IS 875 part 3. For the wind speed value, refer to the map in the IS 875. Consider that the building is being constructed in Bangalore. For the wind speed map, you can see that Bangalore falls in the pink colored region, which refers to a wind speed of 33 meters per second. In the IS 875, you can refer to the wind speeds for major cities of India from a table in the Appendix A without checking in the map. This is illustrated here. Scroll down towards the end of the IS code to Appendix A as shown. It lists the wind speeds of some of the major cities of India. Locate Bangalore from the list and you can see that the wind speed matches with the one you had found out from the map, which is 33 meters per second. For any other place which does not fall on this list, you can directly refer to the map. Change the value of the wind speed to 33 in the software. Now for the terrain category option. Go to the 5.3.2.1 clause in the IS code as shown. Read the definitions of the categories 1, 2, 3 and 4. You can notice that the most apt category for a building constructed in Bangalore will be category 3. So change the terrain category factor to 3 in the software. Again for the structure class, go to the structure class definitions under clause 5.2.2.2 of the IS code as shown. The length and breadth of the building plan is 24 meters each. The height of the building is 23 meters. That is 5 floors of 4 meters height each plus the ground floor of 3 meters height. From the IS code, the greatest horizontal or vertical dimension, which is 24, falls within the 20 meter to 50 meter range. Therefore, the structure class will be B. Select the structure class B in the software. Now for the risk coefficient factor, go to table 1 of the IS code. As already discussed in the previous learned video, take the value of the risk coefficient factor as 1. Now for the topography or K3 factor. Go to the clause 5.3.3.1 of the IS code. The city of Bangalore will be within 3 degrees range in the upwind slope. So take the K3 factor as 1 also. In the exposure height option, keep the default option as shown. Then click on OK. The wind load has now been properly defined. Click on OK to exit the load patterns dialog box. In the next video, you will learn to apply wind loads to the claddings. Thanks for watching.